Okay, here we have a very simple table of x values, which are 2, 4, 8, 10, 12, and 3, 5.5, 5, 6, and 10. Here we have like a scatter diagram, and what I want to do is, first of all, if we just click on the first one here, we can plot those points on the graph. So here we have all these points plotted on the graph. Now, if we click the next one, we will see a regression line. We have to move the sliders a little bit. So what we want to do is try to draw the line of best fit. So we have to change the gradient and to make it look like okay. So I'm going to say that that looks like okay. Now, the regression line, what it does, it measures the distance from each point, vertical distance from each point to the line, whether the point is below the line or above the line. And the idea is, because some of the points go above and some go below, then the idea is that we draw a square, and we draw the square by doing this. Okay, so these squares are drawn in, and the idea, this is what called the least squares, is that we try to keep this square a minimum. So what we have to do is, if we click this one, we get the sum of all these squares. So you can see if I change it, the sum changes. So the idea is to get the sum the smallest, and we can adjust the lines and the gradients. So we had 7 there for a minute, so let's see if we can get back to something like 7, and we can adjust it so we get, oh, that's much bigger, so we need to go down a bit. It's a bit of a fine adjustment. Right, it's smaller there, and again we can move this one, maybe we can make it a bit smaller. It's getting bigger. It's got a bit bigger. Okay, now a regression line will always go through the means. So we've clicked the means, so we're fairly close to it now. We can see that we've actually modelled it fairly closely. We've actually modelled it, so it's got very close. And if I click here, this is actually the target one. This is actually what it is. It's 0.52x plus 2.17, where R gave us 0.84, which is a reasonable degree of correlation. So if I move this, so it says 0.52, sorry, 0.52, and move this one up till it says 2.17, then we can see that the square area, the sum of the area squares is quite low, 7.78. Okay, and actually the two lines coincide. Okay, so it's slight difference because of the number of decimal points. Okay, so the idea is to try and make these squares a minimum area. That's why it's called the least squares line of regression.